everyone. This is the Unit 1 Number Systems Assessment Study Guide. So we're getting ready for our first assessment. And we're going to take a look at question 1. And we're going to write an equivalent fraction to the repeating decimal 0.08. Now, I want you to remember one thing. That if you have multiple choice answers, you can always take your calculator and use that to your advantage. So if you know that you have, if you have answer choices, you can do the numerator divided by the denominator. So you would, for example, let's say it was 3 over 5. You would do 3 divided by 5 in your calculator. And you would check to see which one of those answers looked like this. So if you have multiple choice answers, you can always do that. But let's look at it the way that we did it in class. So if you remember, we did x equals 0.08 repeating. And we said because there were 2 decimal places behind the decimal, we would make 100x, 2 zeros, 100x, and that would be 8.08 repeating. And we've kind of got this little phantom 0 here, but we really don't need it because we know that if we move the decimal over 2 places, we would get 8. Then we're going to subtract that x, and we're going to subtract that 0.8 repeating off of each side, and we end up with 99x, and we end up with 8. Then we're going to look at our one-step equation, divide by 99 on each side. So x equals 8 over 99. But if I had my answer choices available to me, I would do 8 divided by 99 in my calculator and double check to make sure I was correct. Number 2, it says if 6 is less than the cubed root of a, and that's less than 7, which of the following could be the value of a? Well, I know my cubed roots, so I'm thinking of my cubed roots. So remember, we've been doing quiz trade with our cubed roots. So we've got to think 1, 8, 27, 64, 125. Okay, so that's 1, 2, 3, 4, 5. So let's think about 6. Well, I have my calculator available, so I'm going to do 6 times 6 times 6, and I get 216. Well, I know that the number has to be greater than 216. So it can't be 200, it can't be 216, and it has to be less than 7 cubed. So I'm going to do that one, 7 times 7 times 7. And I get 343. So I know it can't be 350, so it's going to have to be 300. Question number 3, which statement is true? So we've got the square root of 10. Okay, so I know that if I'm doing the square root of 10, I have to think of my perfect squares that are less than and greater than. So I've got 9. I'm going to put my little 3 there. And then my next perfect square would be, 16? And I'm going to put my 4 there. Okay, so my first subtraction would be 10 minus 9, and I get 1. And then 16 minus 9, and I get, 7? Yeah, that's right. Then I'm going to do 1 divided by 7 in my calculator. And I've got to go to the first place behind the decimal. So 4 tells me, because I get 0.14, the 4 tells me not to round up. So I'm going to get 0.1, and I take the lower of the two square roots. So it's going to be 3.1. So let's look at our options. Okay, so the square root of 10 is less than or equal to 3.4. Well, that's looking pretty good. It's not greater than. Okay, so now let's think. 12 is not a perfect square. I know that for sure. The square root of 12 is greater than or equal to 4.3. Okay, well, I've got 12, and I know that that's going to be 9 and 16 as well, right? Got my little 3 and my little 4, and I know that I'm going to do 12 minus 9. I'm going to get 3. I'm going to do 16 minus 9, and I'm going to get 7. So I'm going to do 3 divided by 7 in my calculator, and I get 0.42. The 2 doesn't tell me to round up, and I have to take my lower of my square root, so I get 3.4. So that's not correct either. All right, what is the fraction? What fraction is equivalent to 3.7 repeating? Okay, so I know I have a whole number, so I'm going to deal with the 0.7 part. Okay, so I know that x equals 0.7 repeating. So I know 10x equals 7.7 repeating. So I'm going to subtract x, and that means I'm going to subtract the 0.7 repeating. So I end up with 9x, and I end up with 7. So I'm going to divide by 9 on each side because I have a one-step equation now. And so x equals 7/9. So if I was going to rewrite this, I would have 3 and 7/9. All right, which of the following is an irrational number? So I know my irrational numbers are my 2-year-olds and my preteens. Remember, those are my people with big emotions. So when I think about my foldable that I have in my math notebook, I know fractions are rational numbers. I know terminating decimals are rational numbers. And I know perfect squares are rational numbers. So that one has to be my irrational number, because that one in particular, 43, is not a perfect square. So that one's going to have a never-ending decimal that doesn't have any pattern or repeating. All right, which integers, when placed in the box as shown, will make the inequality true? All right, so I know that I have a negative here, so that means I'm going to eliminate the 2 positives. So I know that I have negatives. All right, so I'm going to have to think, all right, if I have 70 here, what's going to go on each side? So I know that 64 and 81 are going to be my perfect squares that surround that 70. So that's going to be 9 and 8. So it's going to have to be C. All right, which number is a rational number that can be converted into a fraction? Well, we just talked about irrational numbers, so we want a rational number. Well, remember, our first experience with irrational numbers was pi, and so this one is pi, so we got to eliminate that one. 8 is not a perfect square. Now, this one is a perfect cube, but it doesn't have that little 3 there, so this one's out. This one has these dots right here, which tells me it goes on forever, so this one's out. This is a repeating decimal that can be converted into a fraction. All right, so this one says put the following fractions in order from least to greatest. So I'm going to use my calculator here, and I'm actually going to divide the numerator by the denominator. So in my calculator, I'm putting 35 divided by 295 in, and I get 0.1186. All right, then I'm going to try the next one. I'm going to do 345 divided by 4976, and I get 0.0693. All right, and then I'm going to do my last one. 13 divided by 245, and I get 0.0530. Okay, so now I got to look at my place value, and I've got to remember from, now this would be early elementary school, and I have to think, okay, I'm going to think in terms of money because that's the way I like to think. So this is 5 cents, 6 cents, 11 cents. So I know that 13 over 245 is the smallest. 345 over 4,976 is the middle. And 35 over 295 is the biggest. So that would be my order. So remember, every time you're doing your numerator divided by your denominator. All right, the amount of solution used in science experiment was 0.48 repeating. Write a fraction that's equivalent. So now if I have multiple choice, I'm going to divide my numerator by my denominator and check. But if I don't, I'm going to have to do it the way we learned in class. So x equals 0.48. And there are 2 places behind my decimal. So I've got 100x equals 48.48 repeating. Then I know that I'm going to subtract x and 0.48 repeating off to get rid of that repeating part. So I'm left with 99x equals 48. Then I've got a one-step equation, so I'm going to divide by 99 so I can get x by itself again. So I have x equals 48 over 99. Now I can reduce this fraction. I can reduce it by 3. I can see that right away. So I've got 16 over 33, I think. Yeah, that looks about right. Okay, so if it were me, I would do 16 divided by 33 and see if I got this in my calculator. All right, write an equivalent fraction, and this time, if you look carefully, only that part's being repeated. So this one's going to look a little funny. Okay, so I only have 2 numbers that are being repeated. So I've got x equals 0.027 repeating. So I'm going to have 100x equals 2.72 repeating. Okay, because I moved my decimal 2 places over. I still have that like phantom 0 here because I moved that decimal 2 places over. So now I'm going to subtract my x on each side. All right, so I get 99x. Now I want to make sure that I do this correctly. So I'm going to put this in my calculator and I'm going to put in 2.72727272, just a whole bunch of 72s. Then I'm going to subtract off 0.027272727, and I'm going to hit the enter sign, and I get 2.7. Divide by 99, and I end up with x equals 2.7 over 99. Now, we can't have a decimal in our fraction. We know that that cannot happen. So how did we fix it in our notes? Well, we actually multiplied by 10 because we got to move that decimal over 1 place. So times 10 in the numerator and the denominator. So we got 27 over 990. All right, question number 11. What is the value of the square root of 7 to the nearest tenth? All right, so let's think about our perfect squares that are going to go around the square root of 7. So we've got 4, and that's going to be a little 2. And then we've got 9, which is going to be a little 3. So I'm going to do 7 minus 4. and I'm going to get 3. And then I'm going to do 9 minus 4, and I'm actually going to get 5. So I'm going to do 3 divided by 5 in my calculator, and I get 6/10. That actually worked out perfect. And I'm going to take the lower of the 2 square roots. So it's 2.6. Alrighty, so now it says, what is the best description of this crazy looking thing? And this looks scary, but remember when we talked to our partner, we said that it might look scary, but we can do it if we break it apart. So I'm going to take a look at this part first, right here. The cube root of 27. So I'm going to list out my cube roots. So I've got 1, I've got 8, I've got 27. So that's 1, 2, 3. Right? Because 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. So I know this one right here is 3. Right? And I know this is 12. So I know that when I'm looking at my options, I know I have natural numbers, integers, irrational numbers, and a rational number. So right now, this right here would be 4, which is a natural number. Because it's a whole number, that's the best description of it. Now, let's say that I had gotten a fraction, like 6 2/3. Well, the best description in that case would have been a rational number, because I've got a fraction, which is a rational number. Let's say I had gotten -3. In that case, an integer would have been the best description. Let's say, and this will not happen on your test, I promise. Let's say I had gotten 53. Oops, let me change colors, hang on. Let's say I ended up with the square root of it's not going to let me change color. Oh, because I'm on the eraser, goofy. There we go. Let's say I ended up with the square root of 53, which you are not going to end up with. Then I would have gotten an irrational number. So you want to look at the best description of the number that you have. So if you end up with a whole number, that's a natural number. If you end up with a negative whole number, that's an integer. If you end up with a fraction or a decimal, then that's going to be a rational number. If you end up with a square root or a cubed root that's not perfect, then that's going to be an irrational number. All right, Terry is playing a math card game and has dealt each of her players 4 math cards. Okay, which person's hand contains all rational numbers? Well, all rational numbers means that they're either, they can't have pi. So let's start eliminating pi. Well, we know it can't be this kid and it can't be this kid. All right, so now we're stuck between these two. It can have repeating decimals. Those are rational numbers. It can have fractions. That'll work. It can have whole numbers. It can have negative numbers. So I'm really looking really close at these two. So you have to have perfect squares if you're going to have a square root. So is 20 or 4 a perfect square? 4 in this case is your perfect square. So John is the correct answer. John has a hand that contains all rational numbers. All right, which fraction is equivalent to 3/100ths repeating? All right, so again, if you have a fraction for answer choices, you have a numerator and a denominator, you can always do the top number, hit divide, and the bottom number and see what your answer choices are. But if you don't, then you're going to have to do it the way we know in our notebook. So we have x equals 0.1 0.03 repeating. Now, if you look really carefully, it's only the 3 that's repeating. So we're only going to do a 10x equals 0.3 repeating. Ooh, that does look weird, doesn't it? All right. So we're going to subtract x, and we're going to subtract 0.03 repeating. So I'm going to make sure I do this in my calculator to make sure that I get an accurate answer. So we're left with 9x. Now I have 0.33333333 in my calculator, and then I'm doing minus 0.03333333. And I get 3/10. All right, so now I'm going to divide by 9, and I get x equals 3/10 over 9. Now, we know that we can't have a decimal in our answer choice. That just cannot happen. So, how are we going to move this decimal over one place? We're going to multiply the numerator and the denominator by 10. And we're going to get 30 over 90. Well, I can reduce that by dividing the numerator and the denominator by 30. And I get 1/3. That doesn't look right, though. Alrighty, let's take a look at the next one. A teacher wrote the following statements comparing the square root of 10 and the square root of 11. The value of 10 is between 3.16 and 3.17, whereas the value of 11 is between 3.31 and 3.32. The value of the square root of 10 is between the whole numbers 9 and 11, whereas the square root of 11 is between the whole numbers 10 and 12. Which statements are correct? Well, I know the square root is not between any whole numbers, so 2 can't be right. So let's check. Let's think about 10 and 11. Well, I know that if I've got a square root, right, of 10, it's going to be between the square root of 9 and the square root of 16, which is going to be 3 and 4, right? So I'm going to do 10 minus 9, which will be 1, and 16 minus 9, which will be 7. 1 divided by 7 is 0.14. And I'll take the smaller of the 2 square roots, so I get 3.1. If I do the second one, if I have 11, it's still going to be 9 and 16. I'm going to do 11 minus 9 this time. 16 minus 9. I get 2 over 7. 2 divided by 7 is 0.3. Still going to use the smaller of the 2 square roots. I get 3.3. So only 1 is correct. Last problem. What is the value of the square root of 18 rounded to the nearest tenth? Alrighty, so if I'm thinking about my perfect squares, I know that I have 16, which is the square root of 4, and 25, which is the square root of 5. And so I'm going to do 18 minus 16, which is 2, and 25 minus 16, which is 9. So 2 divided by 9 in my calculator. And I get 0.2 repeating. And I'm going to take the smaller of the 2 square roots. So 4.2. If you have any questions at all, come see me in the morning. Remember, we went over this in class. So any other questions or concerns or anything, come see me first thing in the morning, and I'll be glad to go over it with you. I hope you have a great rest of your day, and you're going to do great. Bye.